Okay, example 1, the doyen walked to the meeting at 4 miles per hour and caught a ride home in an old truck at 16 miles per hour. So, doyen is somewhere, goes to a meeting, distance there, caught a ride home in an old truck, distance back. That implies the distances are equal, so their distance equals back distance. We don't know what either distance is, but we do know they're equal to each other. So second thing, once we've established the distance relationship, and my categories I'm picking are there and back. You can also go walking, riding, whatever you want to do there, it doesn't matter, as long as you have something to represent it. She walked at 4 miles per hour. She returned at 16 miles per hour. So they give us the speeds in miles per hour. That means time is going to be hours, distance is going to be miles. The total traveling time was 10 hours. Now this happens quite often in these problems. It's going to happen this way on the test, so be ready for this. If you know the total time, let one of the times be t. The other is going to be the total time minus t. It has to be in that order. If you put it backwards, t minus 10 will be wrong 100% of the time. So, total time, t is 1, 10 minus t is the other. 10 minus t, of course, is a binomial, so when we multiply rate times time to get distance, we have to do distributive property. 16 times 10 is 160. 16 times minus t is minus 16t. 4 times t is just 4t. This is the distance there, which equals the distance back. So if I move the 16t to the left, it becomes positive. 4t plus 16t is 20t equals 160. So therefore t must equal 8. Divide both sides by 20. Now the question says, how far was it to the meeting place? Distance there, 4t. So once I figured out that t is equal to 8, which is the time there, 4 times 8 is equal to 32 miles, is what they're asking you to find. So make sure that, don't go all the way through all the trouble to get this answer and then just circle that and say I'm done. Make sure you answer the question they're asking. In this case, they're asking for distance. Number 2, the gun sounded and 4 hours later Bill was 16 miles ahead of Rose. So, the way it sounds to me is Bill and Rose are at the starting line of some race. The gun sounded and they start running. Bill goes some unknown distance. Rose goes some unknown distance, but not as far because Bill was 16 miles ahead of her. So Rose went an unknown distance, Bill went an unknown distance. 16 miles is how much further Bill ran. So based on this picture, Rose's distance plus 16 miles should equal Bill's distance. So again, I don't know either of these values, but that's the relationship between them. So her distance, we don't know, plus the 16-mile gap is equal to his distance. Once we've established that, we got Rose and Bill as our categories. We do our rate, time, and distance. Bill's speed was 15 miles per hour. Rose's speed is unknown. 4 hours later, the way races work is they start at the same time. 4 hours later they're here, so they both run for 4 hours. So Rose's distance is 4r miles, and Bill's distance is 60 miles. So, Rose's distance we don't know yet. 4r though is what we got as an expression representing it. Plus 16 should equal Bill's distance, which is 60 miles. So therefore, move the 16 over here, we get 4r is equal to 44. We divide by 4, we get r is equal to 11. How fast did Rose run? R is her speed, 11 miles per hour, unit of speed. So there's our answer. Number 3, gold bricks sold for $350 each, while pyrite bricks were only $4 each. To stock his booth, Grimsby bought 140 bricks for $15,092. So I'm going to say we have gold and pyrite. As far as number of bricks, we're going to say he has G gold bricks and P pyrite bricks. As far as value, they're giving us the value of each individual brick in dollars. So gold is $350 per brick. We have G bricks, so that's 350 G for gold. We have P pyrite bricks. Each one is worth $4, so 4 times P is the value of all the pyrite bricks. If you look at the two facts they give us, fact 1, 140 bricks involves a number of things, so G plus P is equal to 140. And fact number 2 is $15,092. That has to do with value in the same unit of currency. So I know that 350G plus 4P must equal 15,092. I would probably personally multiply the top equation by -4 to get rid of the P. So I get -4G minus 4P equals -560. P's cancel. 350 minus 4 is 346. 15,092 minus 560, we get a 2 and a 3 and a 5, 1, 4, 5, 3, 2. So we simply have to divide 14,532 by 346. I need to bring my calculator up, so I'll just do a handheld. 14,532 divided by 346 comes out to 42. G represents number of gold bricks, that's 42 gold bricks. The question asks how many of each kind did he buy. So if it's 42 gold bricks, we also need to know how many pyrite bricks. We know that right here, based on this fact, the number of gold bricks, which we just found out to be 42, plus P must equal the number of bricks we got altogether, 140. Minus 42 gets me 98 pyrite bricks. Open that up just in case I need it later. Number 4. We're trying to solve a radical equation, and this is the easiest type of radical equation possible in that the radical on the left equals radical on the right, nothing else in there. So all I have to do to this equation, I'm going to slide it down a smidge here so I can do this. Square this and square this. Squaring the square root gets rid of the square root symbol. So square root of 5x minus 5 squared is simply 5x minus 5. The square root of 3x plus 7 squared is simply 3x plus 7. If I go ahead and solve for x, I'm going to move the 3x to the left, move the 5 to the right, changing both signs in the process. 5 becomes positive, 3x negative. 5x minus 3x is 2x. 7 plus 5 is 12. 2x equals 12, so x equals 6. All we have left to do then is verify that it actually works. So if I try substituting 6 in for x, 6 times 5 is 30, so I get 30 minus 5 underneath the square root is equal to, if I put 6 here, 3 times 6 is 18 plus 7. That's the square root of 25 is equal to the square root of 25. I could go on to take the square roots. It doesn't even have to be nice, pretty square roots like this. Of course, that's 5 equals 5. If this said the square root of 93 equals the square root of 93, they're still the same. So this is the correct answer. Number 5, factor by grouping. Okay, so factor by grouping, our first initial plan for factor by grouping with a 4-term polynomial. Look for greatest common factor. See if there's anything that evenly divides all the objects. So R goes into this but not that, T goes into this and this but not that, so, and then 5 goes into both of those of course but not the other. So there's no common factor to everything. So the second step of factor by grouping is to group and hope that that works. And if it works, great. If it doesn't work, you might have to rearrange it a little bit. Looking at the two groups, I'm going to underline the first group in red. We're looking for a common factor of RT and 5T, which is T. If I factor a T out, I've got a R plus 5 group left over. So taking T out of both objects, R is left from the first term, plus 5 from the second term, in the same order. So this is first, first, second, second. Don't be changing order on these problems. Notice in homework some of you are changing out order on these things. Second group, do this in green. Common factor of J is in both objects. If I take J out of both objects in order, JR, take J out of it, is R is left over, 5J, take J out of it, plus 5 is left over. After you do your first initial group and you pull those common factors out of each group, what should happen is what did happen. I have two objects here. Here's object 1. Here's object 2. looking at the two objects, they should have a common binomial expression. R plus 5 is common to R plus 5. So I'm going to write down R plus 5 as one of the two factors. And then whatever was pulled out, in this case t was pulled out and plus j was pulled out, t plus j is going in the other group. A binomial times a binomial, our typical factored structure, but again, we had to do it by grouping since there were 4 terms. That's the best I can do on that one. That's the correct answer. Number 6, we're supposed to find x. We can see here that we have fractions, and we like to get rid of fractions in these problems. So I'm going to multiply by the common denominator of 5 and 7, which is 35. And I'm going to do it in 2 steps. Step 1, I'm going to actually get rid of the fraction. Step 2, I'm going to distribute where necessary. So 35 divided by 7 is 5, multiplied by the top, which is x. 35 divided by 5 is 7, but notice the minus sign here, so it's actually minus 7 times the top, which is 2 plus x. And then 35 times negative 2, there's no fraction, so it's just straight multiplication, negative 70. All right, so the quotient, 35 divided by 7, 5 times the top. 35 divided by negative 5 is negative 7 times the top. 35 times negative 2, negative 70. And the reason I want to do it in this manner is because of this specific object here. When I do negative 7 times this and negative 7 times that, a lot of you guys are missing this sign here. So minus 7 times 2 is minus 14, and minus 7 times x is minus 7x. And again, it's going to be minus. It'll be minus on the test. It'll be a binomial. There'll be a minus here that has to distribute. So it's going to create an opposite sign. Whatever sign this is, it'll be opposite. But a lot of you are still missing that, so you're not paying close attention to detail on these problems, so you need to do a better job with that. This guy is just negative 70, and this guy is just 5x. So those two things aren't very difficult, but that red object in the middle there, that's where people tend to mess up on these problems. Be very careful. What's left now is I got x's on the left. I also got a minus 14. I'm going to move it to the right. 5x minus 7x makes negative 2x. Subtraction because the signs are different, and negative because 7 is bigger. Negative 70 plus 14 is negative 56. Subtraction because the signs are different. Negative because 70 is bigger. Divide both sides by negative 2, we get x is equal to positive 28. Number 7. Round pi over 4 to the nearest 10,000. Use the pi button on your calculator. So the pi button on this calculator is right here. So, and it's pi divided by 4, I believe is what it says. Yep. So if I type in second that gets me the pi button, divided by 4 equals. And that comes out to 0.7853981634. Okay, go as many decimal places as my calculator will display. Write it on my paper. And then it says to the nearest 10,000. Some of you guys are not counting your decimal places correctly, so let's just look at this. This is the tenths place. Then we got the hundredths. Then we got the thousandths. Then we have the 10,000ths. Okay, and that's what we're looking for, the 10,000ths. 100,000ths, millionths, 10 millionths, 100 millionths, billions, 10 billions, 100 billions, and so on. So it's just the same idea as going in the forward manner, units, tens, hundreds, thousands, 10,000s, 100,000s, millions, 10 millions, 100 millions, billions, and so on. But you just have the TH as you're in the decimal form, the decimal area. So nearest 10,000th would be the 3, and we want to increase the 3 because the next number up is a 9. So I'm going to go with 0.7854 as the correct answer. Not a very difficult problem, but again, it requires you to know your decimal places. Make sure you again use the pi button. Don't use 3.14 to approximate pi. Number 8, find the equation of the following line, and I've gone to the trouble of giving you specific points that I would establish as actual nice integer points for this. So 1, 2, 3, 4, 5, 1 is this one. And this, of course, is 0, negative 2. And this one right here is 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So negative 5, negative 5. All I have to do is use 2 of these points. Doesn't matter which 2 I use. I'm going to use this one. We'll call that point A. And I'll take this one. We'll call that point B. So the two things I need to find the equation line, when it says find the equation line y equals mx plus b, the two things I need are what the slope is and what the y-intercept is. Those are the two things I need to know. So my structure, my answer is going to be y equals something x plus something. So I've got to get a number here and a number here. If b is negative, it's going to be minus. If it's positive, it's plus. Okay. If we start off with slope, to do slope, I have to simply go from point A to point B. First vertically, second horizontally, and I need to worry about direction that I move. So if I'm going from A to B, I'm first of all going up this far, and then from there I'm going to the right that far. So if I take a look how far I moved, and again which direction, I'm moving 1, 2, 3 spaces up. Up is a positive movement. 1, 2, 3, 4, 5 spaces right. Right is also a positive movement. The up and down is called the rise, and the left and right is called the run. And slope is equal to rise over run. So 3/5 in this case. So just like that, I found the slope. The second thing I need is the y-intercept. The y-intercept is simply where the line itself crosses the y-axis, and it's the y-coordinate of that point. So -2 is what b is. The end. That's all finding the equation line is going to be for right now. The y-intercept will be found by inspection, -1, -2. And the slope, how far up, how far over. Up is positive, down is negative, right is positive, left is negative. And again, go from point up or down, and then left or right to second point. Make sure you start here, you end there. Number 9. I'm supposed to add these fractions. First thing I notice about these is that we have a factorable denominator. I recommend always factoring before you try and find a common denominator, because more than likely they already have something in common. So I'm going to leave 3 plus x over x minus 5 as it is. I'm going to leave myself a little bit of space here in case I need to make a common denominator. And then in the second fraction, I'm going to keep 2x on top, but x squared minus 25 is a difference of squares, so x plus 5 times x minus 5. And what we're supposed to notice is that x minus 5 matches x minus 5. They already have that in common. So I need to get an x plus 5. So they both have x plus 5 and x minus 5. This is new, so I need to put an x plus 5 on top. The top was already a binomial, so I need to put it in parentheses also. So the multiplication here is not just x plus 5 times x, but x plus 5 times this whole 3 plus x. So now when I go to multiply the top here, FOIL it, 3 times x is 3x, 3 times 5 is plus 15, x times x is plus x squared, x times 5 is plus 5x. That's still over x minus 5 times x plus 5. And this already had the common denominator, so I didn't change it at all, so it's going to just be minus 2x over x plus 5, x minus 5. All that's left to do now is to combine like terms. So looking at like terms, x squared is the only x squared term on top of anything, so that's just the squared term. I've got plus 3x, I got plus 5x, and I got minus 2x. So all three of these x's, 3 plus 5 is 8, minus 2 is plus 6x. And then I've only got plus 15 as my only number, so plus 15. And then that's all going over my common denominator, either x plus 5, x minus 5, or x minus 5, x plus 5. It doesn't matter the order. Take your pick, whichever one you want for the bottom. And that's it. So get the common denominator, but factor first, compare. They should already have something in common, so you simply have to fix the one that needs to be there. And again, FOIL will be necessary. Combining like terms will be necessary. Number 10. System of equations. We know y is equal to 5x, and also y is equal to -6 plus 2x. So if y is equal to 5x, then 5x itself can be put in place of that y right there. So this becomes 5x. All the rest of it stays as it is, -6 plus 2x. So just basic substitution, y equals that object replaces that y, everything else in the equation stays the same. Now I'm down to a single x in my equation, or just x is a single variable, so move the 2x over. 5x minus 2x is 3x, which equals -6. Divide, we get x equals -2. Once I know what x equals, then I go back to one of the two equations. Take your pick. That says y equals 5x. Y equals 5 times x, we just found to be negative 2. So y is equal to negative 10. And once I know both x and y, I write my answers in ordered pair. X goes first, y goes second. Number 11, find the domain and range of the function shown. Domain equals the set of all x such that less than x less than. It's going to have that structure. Range is going to equal the set of f of x such that less than f of x less than. Okay, so already before I do anything, I didn't even look at the problem yet. I know the answer is going to be like this. X is going to be from some small number to some big number, always less thans. F of x is going to be from some small number to some big number, always less thans. We always get this nice set builder notation. Now, looking at the domain, let me do the domain in red. Domain's all about x. So, here's where the problem starts. The graph starts right there at negative 1, 2, 3, 4. And it ends right here at positive 1, 2, 3. So all I care about with domain is x. I couldn't care about up and down. All I care about is left and right for domain. I'm starting at negative 4. I'm ending at 3. So starting at negative 4, I'm ending at 3. My starting point is a closed, filled-in circle, so I put an equals to there. My ending point's an open circle, so I just leave it less than, the end. There's the domain. As far as range is concerned, I'm going to do the range in green. Range is all about f of x, the height of the function. Okay, y or f of x, take your pick, they mean the same thing. Okay, the function's lowest point is 1, 2, 3 down, and its highest point is 1, 2, 3 up. So it starts at negative 3, ends at positive 3, so the small number, negative 3, big number, positive 3. It starts at a filled-in circle, equals. It ends at no circle. No circle's implied filled-in circle. So no circle is just as good as a filled-in circle. So it's an equals to there also. That's the answer to that. That's all domain and range of one of these graph things is. Even though there's a hole here, that hole's filled in right there. So every value of y has been taken into account for this whole thing. So all you really have to focus on is at the endpoints, is there a closed circle? They'll make the equals. At the endpoints, is there a closed circle? Yes, equals, no, just less than. So always less than, sometimes equals to. Small number, big number. Where does x start? Where does x end? Where does f of x start? Where does f of x end? Number 12. Okay, this big expression here we have to simplify. Got brackets, got powers, got parentheses inside of brackets. I'm noticing, just looking at it, that this bracket ends here, and this bracket begins here, and those two brackets are being subtracted. So I have to evaluate this whole thing and evaluate that whole thing before I worry about subtracting them. Let me look at the red one first, and I'll work the blue one out afterwards. So if we just look at the red one, minus sign outside is going to stay minus, nothing's happening to it. I'm going to put the bracket down here and here. As I look at the pieces, negative 4 to the 0 and negative 2 squared are powers. A cube root is also in the family of powers, so I want to do powers first within that bracket. So negative 4 to the 0 power is going to be negative 1. It's negative because the 0 is right next to the 4, not outside the parentheses. Only 4 is being raised to the 0 power, the minus sign isn't. If the 0 were located up here outside the parentheses, now it's going to affect both. Negative 2 squared does have the 2 outside the parentheses, so it's negative 2 times negative 2 makes a positive 4. Then I have this minus negative 3 that's just kind of hanging out. And then I got minus, the cube root of negative 64 is negative 4. All right, 4 times 4 times 4 is 64. 3 negatives make a negative, so there you go. Next thing I'm going to do is I'm going to do any multiplication. That's multiplication. Minus minus is under the category multiplication. Here minus minus also. So I've still got this negative outside the bracket. I've still got my bracket. Negative 1 times 4 is negative 4. Minus minus 3 is plus 3. Minus minus 4 is plus 4. Still got a minus outside the bracket. Negative 4 plus 3 is equal to 3. The negative and positive 4 cancel, even the 3. And then minus 3 is just minus 3. So all this stuff here became minus 3. Kind of did it in pieces, worked it out as I went. There's a minus sign here, there's a minus sign here, there's a minus sign here, there's a minus sign here. So at this point I want to work out the blue bracket. Inside the blue bracket I've got a parentheses. Parentheses happen before anything else. So negative 2, negative 4 plus 8 is equal to positive 4. This negative 2 is being multiplied by the parentheses, so negative 4 and 8 evaluate to 4. Subtraction because the signs are different. Positive because 8 is bigger. Then negative 2 is being multiplied by that, so I'm going to get negative 8 still inside the brackets. Minus 8 is plus 8. Negative 3 plus 8 is equal to 5. Evaluate that down as much as you can. Evaluate that down as much as you can. Then add or subtract based on the signs at that point. Number 13 is this formula we've been seeing recently in homework and on the last test even. On the last test I said A equals B equals C equals. This one I'm a little bit more, I guess, creative with what A, B, and C are. B is equal to negative 1. That's ready to go. I don't know what A or C equals, so I want to start there. So if I have, of course, A over 2 equals, I move the 1 over. 2 minus 1 is 1. If A divided by 2 is equal to 1, A must equal 2, because you've got to double both sides. So basically, times 2 gets rid of the fraction, times 2 gets the answer. Over here for C, 2C plus 14 equals negative 16. Move the 14 over, becomes negative. 2C is equal to negative 30, so therefore C must equal negative 15. Now, looking at this expression we're trying to evaluate, I want to focus on the pieces of it. I've got a negative B. I got b squared minus 4ac inside a radical, and I've got 2a. And that's kind of how I want you to look at this formula. So x equals that structure. And for that structure, we have to do 3 specific things. So again, I've got something here. I've got something here. And I've got something down here. I want to fill in those 3 holes with what it says to do. So look at this piece first. Minus b means change the sign. So b is negative 1. We change the sign, it becomes positive 1. That's all that is. Look at the bottom piece here. Let's go with purple. That'll probably contrast well. Purple's, this part down here says 2 times a. Well, a is equal to 2. 2 times 2 is equal to 4. Okay, that's all that is. So again, those 2 pieces are real simple. Minus b, change the sign of b. 2a, double whatever a is. The third piece is a little bit more complicated, so I like to do that in pieces. So b squared minus 4ac. B squared means to square b. Squaring a letter means to square its sign and its number. So negative 1 times negative 1 is equal to positive 1. This is always positive. This piece is. All right? And it's always subtraction here. Minus 4 times a times c. A is 2 and c is negative 15. This is always a minus sign right here, but based on the numbers that are being put in here, in this case these 2 numbers, sometimes you get 2 negatives, so it changes to a plus. So minus minus makes a plus. 4 times 2 is 8 times 15 is 120. 1 plus 120 is 121. So that's how you first create the structure of this object, and then we need to evaluate it if possible to the extent we can. The square root of 121 is 11. I'm going to go ahead and say that's going to happen on the test. This should be a perfect square underneath the radical, so you should expect to be able to evaluate that. And it's plus or minus, it's always plus or minus here. Plus or minus means to both add and subtract. So we get 2 answers. Both of them have 4 for a denominator. 1 plus 11 is 12. 1 minus 11 is negative 10. 12 divided by 4 is 3. Negative 10 divided by 4 is negative 5 halves. I'm expecting to get answers looking like that when you do those problems. There is an x equals, so make sure you put the x equals on your answer. Number 14, find the area of this figure. Corners that look square are square, dimensions are in inches. So let me just break it down into the most basic figures there are there. I see a rectangle, a triangle, and a semicircle. So if we look at this in 3 pieces, let's go piece 1 is this triangle. Alright? This is 6, so this is 6. This is 17 and that's 6, so this must be 11. This is 4, radius 4 up, 4 down makes that 8. So that means this also is 8. So looking at the triangle, the height of the triangle is 8, the base of the triangle is 11, the area of the triangle is simply going to be 1/2 times the base times the height. Half of 8 is 4 times 11 is 44. Moving on to the rectangle. The rectangle has a width of 6 and a height of 8. Width times height is equal to 48. So that's the area of the rectangle. And then the semicircle, all we need for a semicircle area is the radius. And the area of the semicircle is just going to be pi times the radius squared divided by 2. In this case, the radius of 4, we square that, we get 16. Pi times radius squared is half a circle, so divided by 2. That comes out to 8 pi, approximately 25.12. Triangle 44, rectangle 48, semicircle 25.12. The overall area of the whole thing is simply going to be the sum of these three numbers. So 44 plus 48 plus 25.12 comes out to 117.12 inches squared. Just verify 44 plus 48 plus 25.12 comes out 117.12. Okay. So number 14 on the test is going to be a similar looking figure. I'll of course change the dimensions up a little bit, but it should work out similarly to that. Number 15, surface area of a regular square pyramid. The surface area formula for a pyramid is B plus 1/2 PL. B is area of base, P is perimeter of base, L is slant height. So, first thing I want to do after I've established what formula I'm going to use is I want to evaluate the area of the base, the perimeter of the base, and the slant height. Okay, we'll start with slant height because it's easy. The slant height is the distance from the edge up to the point at a right angle to the edge. So 16 would be the slant height. You're going to find that by inspection on the test. You find it by inspection here. The base and the perimeter, these two things, the area and the perimeter of the base, are based on the base. And this is a square pyramid, it says. That means the base is a square. It's 14 by 14. The area of 14 by 14 is 196. The perimeter is 14 plus 14 plus 14 plus 14, which is 56. So the area of the base is 196, the perimeter is 56. All right. That's all you have to do on this problem. You find those three values before you worry about this formula. You want to know what these three things equal. Once you know those three things, the formula is very simply states SA is equal to whatever this is, 196, plus 1/2 times the product of these two other things, 56 times 16. That's 196 plus 1/2 times 56 times 16 comes out to 448. And 196 plus 448 is 644. And the unit of dimension here is feet, so feet squared. And that's how you find the surface area of a pyramid.